Welcome to the Lavish Club, where dreams come to life. A realm of opulence and joy, away from daily strife. Lights aglow, music in the air, a haven so divine. Step inside and join the dance. Let your spirit intertwine.
Journey to the Sun is a presentation on ISRO's solar mission. This presentation will cover the objectives, challenges, and achievements of the mission. The presentation will also highlight the importance of the mission in advancing our understanding of the Sun and its impact on Earth. ISRO's solar mission. ISRO's solar mission was launched in 2008 with the aim of studying the Sun's corona and solar wind. The mission has two spacecraft, Aditya-L1 and Aditya-LITE, which will study the Sun's atmosphere and magnetic field. The mission is important for understanding the Sun's impact on Earth's climate and space weather. Aditya-L1 is ISRO's first dedicated solar mission. The spacecraft will be placed in a halo orbit around the L1 Lagrange point, which is a stable point between the Earth and the Sun. The spacecraft will study the Sun's corona, solar wind, and magnetic field. The mission is expected to launch in 2022. Aditya-LITE. Aditya-LITE is a small satellite that will study the Sun's corona in the visible and near-infrared regions of the spectrum. The satellite will be placed in a low Earth orbit and will complement the observations of Aditya-L1. The mission is expected to launch in 2021. Objectives of the mission. The main objectives of ISRO's solar mission are to study the Sun's corona, solar wind, and magnetic field. The mission will also investigate the mechanisms responsible for heating the corona and accelerating the solar wind. The data collected by the mission will help in understanding the Sun's impact on Earth's climate and space weather. Challenges of the mission. ISRO's solar mission faces several challenges, including the harsh radiation environment near the Sun, the need for precise pointing and control of the spacecraft, and the development of instruments that can withstand the extreme temperatures and pressures. The mission also requires a high level of coordination and collaboration between international space agencies. Instruments on Aditya-L1. Aditya-L1 will carry 7 instruments to study the Sun's corona, solar wind, and magnetic field. The instruments include a coronagraph, a solar X-ray monitor, a solar ultraviolet imaging telescope, and a magnetometer. The data collected by the instruments will help in understanding the dynamics of the Sun's atmosphere. Aditya-LITE will carry 2 instruments to study the Sun's corona in the visible and near-infrared regions of the spectrum. The instruments include a visible emission line coronagraph and a near-infrared imaging spectrometer. The data collected by the instruments will help in understanding the physical conditions and processes in the Sun's corona. I.S.R.O's solar mission has already achieved several milestones, including the successful development and testing of the Aditya-L1 and Aditya-LITE spacecraft and instruments. The mission has also established international collaborations with space agencies in the US, Europe, and Japan. The data collected by the mission will contribute to our understanding of the Sun and its impact on Earth. Conclusion. ISRO's solar mission is a significant step forward in our understanding of the Sun and its impact on Earth. The mission will help in predicting space weather and its effects on communication and navigation systems. The data collected by the mission will also contribute to our understanding of the Sun's influence on climate change. We look forward to the exciting discoveries that will be made by this mission.